Imagine you're standing outside on a bright sunny day. Birds are chirping, the air is warm, the sky is blue. Then, the sun disappears. Not slowly. Not after billions of years. Just poof, gone. No explosion, no warning, no sunrise tomorrow. One moment it's there, the next, it's blackness. What would happen to Earth? Would we freeze instantly? Would we fly out of orbit? Could humanity survive without the star that gave us life? Today on Cosmic Clarity, we're diving into one of the most terrifying and fascinating cosmic what-if questions. What if the sun suddenly went out? And trust me, it gets weird fast. Before we dive into what would happen, let's get one thing straight. The sun can't just turn off like a light bulb. It's a massive ball of plasma, powered by nuclear fusion, converting hydrogen into helium in its core. This process releases immense energy, enough to shine for billions of years. When stars like our sun die, they don't just vanish. They go through stages, expanding into a red giant, shedding their outer layers, and eventually collapsing into a white dwarf. This takes millions of years, not seconds. So, to imagine the sun suddenly going out, we have to break the laws of nature a bit. This is a purely hypothetical science fiction level event. But for the sake of thought experiment, let's say, the sun instantly stops producing light, heat, and gravity all at once. What now? Here's something mind-bending. If the sun disappeared right now, we wouldn't notice immediately. That's because light and gravity both travel at the speed of light, about 300,000 kilometers per second. So for about 8 minutes and 20 seconds, life on Earth would continue as if nothing happened. The sky would still be blue, the birds would keep chirping, your phone would still be overheating. But after those 8 minutes, the sky would go completely black, even during daytime. The moon, no longer illuminated, would vanish from view. The stars would suddenly pop into full visibility, everywhere. And the Earth? It would instantly veer off its orbit, no longer held by the sun's gravity. We wouldn't be orbiting anything anymore. We'd just drift. Now let's talk temperature. When the sunlight stops, photosynthesis stops immediately. Plants begin to die. Crops stop growing. The food chain starts to crack. Surface temperatures on Earth start to plummet. Within 24 hours, the average global temperature drops by about 15 degrees Celsius, 27 degrees Fahrenheit. That's like going from a spring day in California to a freezing night in Siberia overnight. But that's just the beginning. With no sunlight to warm the atmosphere, weather systems collapse. Winds die. Clouds stop forming. Rain becomes rare. It gets eerily still. Oceans, having high heat capacity, will take longer to freeze, but the surface will begin to ice over quickly in colder regions. By the end of the first week, Earth's surface temperature drops below freezing globally. Some species, like deep-sea vent organisms or extremophiles, might not notice anything. But surface life? It's in trouble. Power grids begin to fail. Solar panels are useless. Crops are frozen. Animals begin to die off en masse. Humans scramble for heat. People take shelter in basements, bunkers, or any underground structure that can trap warmth. Some may even dig into old coal or nuclear-powered stations to keep themselves alive. Meanwhile, the planet drifts through space, away from the former center of its orbit, alone, dark, and dying. After 30 days, Earth's surface is a frozen wasteland. The average temperature drops to minus 73 degrees Celsius or minus 100 degrees Fahrenheit. Most of the oceans are now frozen on top, with liquid water below trapped in pitch darkness. Only volcanic or geothermal regions remain warm, if barely. Humanity, if it survives at all, lives in deep underground cities, powered by nuclear reactors, geothermal energy, or massive chemical batteries. Food comes from hydroponic farms, artificially lit, climate-controlled, and limited in scale. Meat production? Basically impossible. Water recycling? Mandatory. Communication with the outside world breaks down. Nations collapse. The few remaining groups of humans become isolated and highly dependent on technology to survive. This is no longer the Earth we know. With the sun gone, the rest of the solar system begins to fall apart, gravitationally speaking. Every planet, moon, asteroid, and icy rock was once in a delicate orbital dance, held together by the sun's gravity. Without that anchor, everything goes rogue. Earth isn't the only one drifting into space. Jupiter, Saturn, Mars. All of them are now on straight-line trajectories into the void. Some moons may crash into their parent planets. Asteroids may change course and scatter unpredictably. The Kuiper Belt and Oort cloud could be flung wide open like cosmic shrapnel. In time, collisions could become common. Whole regions of the solar system might destabilize, especially around the former orbits of planets. It becomes a graveyard, a shattered ballet of celestial bodies, and Earth is just one frozen rock among them. So now comes the big question. Could we adapt? Could humanity actually survive permanently without the sun? Surprisingly, some scientists say, maybe. If we act fast and prepare in advance, underground survival bunkers powered by nuclear fission or geothermal heat might be possible. Places like Iceland with natural geothermal vents could become temporary sanctuaries. There's also the possibility of building giant habitat domes in volcanic regions, insulated against extreme cold, using artificial lighting to grow food. In theory, humanity could retreat into the Earth itself, living like cosmic mole people, cut off from the sky we once looked up to. But this survival would be extremely limited. Resources would be scarce. Populations would need to be small. Any mistake, a power failure, a breach, a failed crop cycle, could be catastrophic. It wouldn't be a future of thriving. It would be a future of enduring. To ground our cosmic nightmare in real science, let's take a moment to turn to the work of Dr. David Stevenson, a planetary scientist at Caltech. In a lecture on stellar dynamics and solar dependency, he posed a question to his students that mirrors ours today. What would Earth's biosphere do if its source of energy were simply switched off? He wasn't being dramatic. He was pushing students to understand the incredible fragility of Earth's ecosystem and its total dependence on solar input. Dr. Stevenson proposed that even though the sun is incredibly stable compared to other stars, we shouldn't think of that stability as a given. He explained that we've had only a short window, about 4.5 billion years, of relatively peaceful conditions. But stars can undergo unexpected transitions. Not instantly, of course, but unpredictably. In one of his more speculative papers, he explored what would happen if a sudden event, like a false vacuum decay, rendered the sun inert. Though this is an extraordinarily unlikely quantum event, it is theoretically possible. The sun's fusion would stop, energy would cease to radiate, and within minutes, the solar system would begin its descent into cold silence. While this sounds like the stuff of science fiction, Dr. Stevenson emphasized the educational value of such scenarios. They allow scientists to model biosphere collapse rates, study energy storage limits, consider survivability windows, and examine how life might relocate, say, into deep ocean thermal zones. He stressed that such models aren't just intellectual exercises, they offer insights into how we might respond to more likely disasters, nuclear winters, asteroid impacts, or even the artificial dimming of the sun due to volcanic super-eruptions. And then there's Dr. Brian Cox, the British particle physicist and science communicator. In a segment for the BBC's Wonders of the Universe, he highlighted that without the sun, life has no redundancy. Cox explained, The Earth is not self-sustaining, it is powered. That power source is the sun. Remove it, and our world is a battery draining to zero. That metaphor is striking, because a battery can keep a device alive for a while, but eventually it dies. Cox explored alternative energy strategies in the event of solar failure, not because it's imminent, but because it forces us to ask, what happens to a civilization when its fundamental assumptions fail? His conclusion was sobering. Even with nuclear or geothermal technologies, only small groups could survive long-term. The level of coordination, engineering, and sheer will required would be unimaginable. But Cox also reminded us, we are a species that adapts not just biologically, but intellectually. It is our knowledge that gives us a fighting chance. In combining the perspectives of Stevenson and Cox, a new layer is added to this scenario. It's not just about survival, it's about resilience. It's about recognizing our place in a finely tuned cosmic environment, and how little stands between balance and extinction. Both scientists agree on one thing: the sun is not optional, and our relationship with it should be treated with awe, gratitude, and vigilance. In the end, asking, what if the sun suddenly went out, isn't just a curiosity, it's a warning bell, a reminder of how precious and precarious our little blue world really is. What about building a new sun? Okay, not a real star, but something to replace what it gave us: light and heat. Scientists have proposed futuristic ideas like giant orbital fusion reactors, beaming energy back to Earth, artificial suns built in orbit to radiate light and warmth, or even moving Earth to orbit another star. Yes, with giant thrusters, it's been proposed. There's also the idea of a space ark, building massive ships capable of carrying thousands of humans to nearby star systems. Proxima Centauri, maybe. But these plans require time, technology, energy. And with the sun gone, time is the one thing we don't have. Still, the idea shows how deeply the sun is tied to our existence. Without it, we not only lose our energy source, we lose our sense of direction in the universe. Here's the truth. We often take the sun for granted. It rises, it warms, it glows. It provides life without ever asking for thanks. But this thought experiment reminds us, everything we are, every breath we take, every tree, every drop of ocean, depends on that one star. Its light built us. Its gravity held us. Its presence shaped the entire history of Earth. If it were gone, it wouldn't just be cold. It would be the end of our story, or maybe the beginning of a new one, a story of survival, of adaptation, of remembering that even in darkness, curiosity and knowledge still burn. So tonight, when you see the sunset, don't just look away, appreciate it. Because one day, far in the future, the sun will die, not in an instant, but gradually, beautifully, and inevitably. And by then, we might be ready. Thanks for taking this chilling journey with us through one of the universe's most powerful what-if questions. If you learned something, or just love thinking about the big cosmic picture, don't forget to like, subscribe, and hit the notification bell for more explorations with cosmic clarity. Stay curious, stay warm, and as always, stay cosmic.